Dr. J. Kamala received her BE in Electronics and Communication Engineering from Madurai Kamaraj University in 1989, ME in VLSI Design from Bharatdasan University in 2002, and PhD from Anna University in 2011. She is currently working as Associate Professor in the Department of Electronics and Communication Engineering, Anna University, Chennai. Her research interest includes VLSI design, solar power, controller design, and smart sensors. She has published several papers at national and international journals.
Welcome to the UGC lecture series on agricultural engineering. Today we are going to see about renewable energy part 10. In this part we are going to see about wind energy. It is one of the renewable energy sources and it is sustainable energy because we will be having the wind throughout the year and in all the places, and it can be used effectively to get electrical energy from the wind. The wind energy, we are converting the wind kinetic energy is converted into electrical energy. The wind will be moving, it is having some kinetic energy. It is converted into electric energy. It is cost effective. It requires high installation cost, but we get more power from the wind energy, so it is cost effective. Clean. It does not produce any polluting gases, no CO2 emission or anything, so it is clean, environmental friendly. And for installation purpose and maintenance purpose, we need frequent work, so it creates job. It is a domestic source of energy. It can be used for single house residential and commercial application. It could be built on existing farms or in empty spaces, and it is sustainable. We can continuously generate electricity using wind energy. The wind energy is produced or used in different ways. What are the types of wind energy generators? If we see according to the power output, electrical power generated from the wind, we can have three types. First one is distributed wind energy generator, and it is for generating a power less than 100 kilowatt. It is used for a home or farm or small business. It is standalone, that means it is not connected to the power grid. It is used with, if the energy generated from the wind is not sufficient, we can use with the photovoltaic panel and diesel, then it will be a hybrid energy source. So distributed energy source means we can say the wind energy is completely used by the home, it is not connected to the grid. Next one is utility scale. When the power produced from the windmill or turbine is greater than 100 kilowatt, then and it is connected to the grid, then we say it is utility scale. For example, the energy generated from this windmill is connected to the grid. From the grid, it can be used for any application, for industry application, or it could be used for home, residential, commercial, shops, anywhere we can use. That is called a utility scale. Next type of wind energy we call is offshore. That is very high power is generated through wind turbines. They are installed in larger water bodies like ocean. It is massive and taller. For example, like this, the wind turbines are installed in the seashores or in the ocean. More number of wind turbines are installed there, and we get more power output from the wind. That is the offshore wind energy. This classification is based on the how much power we are getting from the wind turbines and how they are connected. That is the classification. And another classification is based on the purpose or type of energy, type of application it is used. In the olden days, they are having windmills. It converts mechanical energy, or wind energy is converted into mechanical energy, and it is used to grind grains, pumping water, etc. It is not used to generate electricity. It is used to provide some mechanical energy to perform some functions. That is called windmill. But nowadays they are interchangeably using windmill and wind turbine. So next one is wind turbine. It is a highly complex machine used to generate electricity. Wind turbine is used to convert wind energy into electrical energy. It is a highly complex machine. And another one is wind farm. Wind farm means more number of wind turbines are installed, and they are all interconnected with each other, and they are used as a single plant to produce more electricity. So for in this diagram, if we see a single wind turbine is called wind turbine. Single structure is called wind turbine. If you have more number of wind turbines connected together and they are all interconnected and they are used as a single plant, means it is called wind farm. Next one is how the wind turbine works. What is the inside wind turbine? If you see the wind turbine, it is having some blades. For example, if this is the wind turbine, a tower is there, and at the top we are having blades. At the center we are having a structure called hub. This structure hub provides all the circuits required to convert the wind energy into electrical energy. The wind energy is accessed by the blades. The circuit inside the hub, that is at the center, it converts the electrical wind energy into electrical energy. Inside that hub we are having these components. So these are all blades. We are having 3 blades. Okay. And the blades are attached with the hub through rotors, and the blade motion is connected to other elements through low speed shaft. Here we will be having a gearbox and a generator. Through the gearbox, the low speed motion of the blades are converted into high speed motion through the high speed shaft. The gear converts the low speed motion into high speed motion. This generator, according to the speed, generates the power, electric power. For that we are having controller, and according to the wind direction and wind speed we get different current output. To have regulated current output, the controller is used. It controls the motion of the blades also. We are having yaw motor, yaw drive, and brakes are also there, so that we get optimum or maximum efficiency from the wind energy generated. To measure the wind power, anemometer is also used, and this structure is called nozzle. So wind turbine consists of these equipments inside it to convert the electrical energy into to convert the wind energy into electrical energy. So first structure we are having is foundation. That is in the previous diagram. If we see, this is the wind turbine is installed on the ground, and this wind turbine is very tall, and we need proper foundation to hold the structure. So first we require some foundation. Above the foundation there will be a tower, because to get maximum energy from the blades, or the blades are to be positioned at a higher place, so that we will get more energy from the wind. Wind will be flowing high in the high altitudes. If at the ground level wind flow is less, so we are using a tower to hold the blades at a higher altitude level. So next, tower, mostly it is in the range of 75 to 110 meter, and it is equal to the height of the diameter of rotating blades. It is designed like that, that height is equal to diameter of rotating blades. Next, a rotor. That rotor is attached with the blades. Hub, it holds all the electronic and electrical equipments necessary for the rotation of the blades, as well as to generate electricity from the wind. That is the hub. Next one is nozzle. It includes all electromechanical parts, generator, gearbox, etc. The front portion of the hub is the nozzle. And generator, mostly they are using induction generator. We are having synchronous generator and induction generator. Synchronous generator operates with fixed speed, but wind speed is not always constant, it is varying. So to accommodate it, induction generator is used, because it supports variable speed of operation and we get maximum energy from the wind. So induction motor is used for the generator. Induction generator is used for the generator application. And inside the wind turbine, these are the blocks we are using. Here the blade motion is converted into, the blades are rotating at a lower speed. So the low speed shaft is converted into high speed shaft, and it is attached with the generator. For environmental hazards like storms or some environmental hazards, the blades may get damaged. To control it, there will be a brake also to stop the motion of blades, and during maintenance operation also we have to stop the operation of blades. For that, brakes are used. The generator output is alternating current, that is AC. It is converted into DC by a rectifier unit. Again it is converted into AC by a line control unit, and it is connected with the grid. And to operate all these electronic or electrical equipments, we need supply. For that, internal supply unit generator is used, and it is supplying all those things. The turbine controller controls the speed of the wind turbine. The exciter current is controlled by the turbine controller. Output voltage of the controller is given to rectifier. The rectifier unit, that is RU, it converts the AC into DC. Again it is converted into AC, because output from the generator is not constant, it is always varying. Here also we are having maximum power point controller, so that we get maximum power from the wind turbine. DC output is again converted into stabilized AC and then fed to the grid. These are the internal block diagram inside the hub, that is the wind turbine. So wind turbines we have seen first classification based on the usage, how much power it is producing and how is it used. Then we have seen what are the internal functional blocks of the wind turbine. Now we see about different types of wind turbines according to the construction. The first one is horizontal axis wind turbine. It is called HAWT. Horizontal axis means we are having the wind turbine axis blades, that axis is horizontal, that is called horizontal axis. So these type of wind turbines are called horizontal axis wind turbines, and it can have any number of blades. Even you can have single blade, two blade, three blade, like that. It is a common type of wind turbine mostly used. Two or three or more long blades, they are like airplane propeller, they are pushed directly towards the direction of the wind, that is the horizontal axis wind turbine. It is used to generate power in the range from 50 watt to 4.5 megawatt, and mechanical and aerodynamic balance is better if the turbine is having 3 blades. The stability of the structure is more if the turbine is having 3 blades. So most of the wind turbines will have 3 blades. Multi-bladed rotor is also used, and it is used for water pumping application. The fixed, and we can have another type, fixed type and variable speed. Fixed speed turbine achieve maximum efficiency if they are operated at rated speed. If it is not operated at the rated speed, it won't be giving maximum output. Variable speed accommodate wider range of wind speed, and it provides optimum output during longer period. For a longer period, it provides maximum output. And the another disadvantage with the wind turbine is, particularly horizontal axis wind turbine, is it generates aeroacoustic noise and it will be disturbing the birds, and it is an environmental hazard to birds and animals. These are the different types of horizontal axis wind turbines. If we see, the first one is single blade. This is the axis, with that only single blade is there. Then 2 blades, 3 blades, multi blades. This is bicycle multi blades. If this structure is for upwind means the blades are in the front side or towards the wind is towards the blades. Downwind means the blades, the wind is behind the blades, wind flow is in the direction behind the blades. And we are having different sail wing, like this we are having different types of structures. The commonly used horizontal axis is this one, the 3 blades, because it is having balancing according to air and structure. It is having more stabilized structure. So this is commercially used. Other structures are used for some particular applications. In this case, counter rotating blades, we are having 2 sets of blades and they are rotate in opposite directions. Like this diffuser, concentrator, unconfined vortex, crosswind paddler and crosswind savannah, horizontal axis wind turbines. These are the different types of horizontal axis wind turbines. Next type of wind turbine is vertical axis wind turbine. They are shorter. It is not taller like horizontal axis wind turbine. It is abbreviated as VAWT. It is shorter. It is wider curved. The blades are widely curved. It is similar to Mixie beaters and they are omnidirectional. In case of horizontal axis wind turbines, the blades are positioned according to the wind direction. In case of vertical axis wind turbines, it is not necessary, it is omnidirectional. In whatever direction we install the turbine, it will convert the wind energy into electrical energy. Here the VWAT wheel rotates in the horizontal plane and there is no vertical motion of the blade. The blades are moving in the horizontal direction, no vertical motion. The tip speed ratio, that is the ratio of blade tip rotational speed to wind speed of VAWT cannot be greater than 1. So, the energy efficiency is less compared with the horizontal axis wind turbine. The blades were designed by blade element momentum method. This method is used to design the blade. The airflow through VAWT, the vertical axis wind turbine, is more complicated compared with the horizontal axis wind turbine. The blade element moment theory is not suitable for its analysis and design. Therefore, there is much less development in the VAWT. Vertical axis wind turbines are not developed much like horizontal axis wind turbines. The vertical axis wind turbines, we are having different types. The first one is based on the wind drag. Wind drag principle is used to design the vertical axis wind turbines. Its structure is like S type, that is Savonius wind turbine. They are cup shaped wind wheel blades for wind speed measurement. It consists of two axis staggered half cylinders. The starting torque is large for this type of wind turbines, that is Savonius wind turbines. The starting torque is large, so it is self starting. A starter is not required for this. The unsymmetrical airflows exist around the rotor, produces lateral thrust to turbine blades. Two or more scoops are used in the anemometers. It is used in flattened vents, high reliability and low efficiency power turbine applications. This is one type of vertical axis wind turbine, that is S type, that is called Savonius wind turbine. Another type of wind turbine, vertical axis wind turbine, is based on principle of airfoil lift. Here the typical application is Darrieus wind turbine. It has various forms including H type and Psi type. The H type wind turbine is simple in structure, but the centrifugal force may generate serious bending stress on its turbine wheel connections. That is the major drawback of this type of turbine. And the flexural blades in Psi type, it bears only the tension without centrifugal load. Therefore, the bending stress in the blades of Psi type wind turbine is reduced or it is eliminated. Only H type is having that problem, that Psi type wind turbine is not having the problem of centrifugal load. So, vertical axis S type VAWT is having a problem of limited tip speed ratio, it is less than 1. But the other type, that is lift type, Darrieus type wind turbines have tip speed ratio, it can reach as high as 6. Therefore, its wind energy utilization is not less than horizontal axis wind turbines. Darrieus type wind turbines are having higher efficiency as compared to horizontal axis wind turbines. The Darrieus turbines have good efficiency, but it produces large torque ripple and cyclical stress on the tower. So, it contributes to poor reliability. The reliability of Darrieus turbines are very less. Another thing is they also require some external power source or additional Savinor rotor to start turning, because starting torque of the Darius type wind turbine is very low. So we need starter for the Darius type wind turbine. And another type of vertical axis wind turbine is gyro mill wind turbine. It is a subtype of Darius turbine with straight blades. The blades of the vertical axis wind turbines are always curved, but gyro mill is having straight blades. It has a variable pitch. The pitch of the cyclo turbine has variable pitch, so it reduces the torque pulsation and it is having self starting. The self starting problem of Darius wind turbine is eliminated in gyro mill wind turbine and it is self starting. So these are the different structures of vertical axis wind turbine, that is the gyro mill or Darius vertical axis wind turbines. If we see, the blades are straight, it is not curved, that is this structure and this turbine. They are classified as gyro mill or Darius vertical axis wind turbine. If we see other vertical axis wind turbines, these structures, the blades are curved in nature like this. They are called Savior vertical axis wind turbines. The blades are curved, it is not straight. These are the different types of vertical axis wind turbines. If we see the advantages of vertical axis wind turbines, the generator is present in the base, that is in the previous diagrams the structure is very short and it is the generator will be placed at the bottom. So the generator is placed in the bottom, so maintenance is very easy. Horizontal axis wind turbines are very tall and it is difficult to maintain. It is easy. Vertical axis wind turbine maintenance is easy and it is omnidirectional. Yaw pitch control is not required because it is omnidirectional, and it can work in turbulent and gusty winds. In all the environmental conditions it is working, it is not having any problem, and it can be used in rooftops, urban area, traffic area, etc. The disadvantages, if you see, the geometry is complex, suffer from wide variation of angle attack and installation problem, less reliable, less efficient because the wind hitting blade on the front are producing torque. Self starting problem on low wind speed. Wind speed is less means it is not having self starting. We need extra technique to start the turbines. So if we compare the horizontal axis and vertical axis wind turbines, with improved structures, vertical axis wind turbines can have efficiency up to 70%. The disadvantages, EMI interference, mechanism of wind steering, airbag, all are required for horizontal axis. For vertical axis it is not required. Blade rotation space is very large for horizontal axis, it is small for this one. Wind confrontation capability is weak for horizontal axis and it is strong. Noise is also less for vertical axis. Noise produced in the turbine is less for vertical axis, so it is more environmental friendly, and failure system is also less. Operation is maintenance is convenient, resolving speed is slow, cable position problem is not there for vertical axis. With more advancements we can use vertical axis wind turbines. Another classification is according to the pitch, whether we can have fixed pitch or variable pitch. Fixed pitch is used for desirable for small machines in remote areas. Variable pitch is preferable for large machines to achieve aerodynamic balance, and it exerts more energy with fixed speed operation. The advantages of variable pitch are high starting torque, wide relatively flat torque curve, higher coefficients of performance, more efficient operation in turbulent winds, lower blade speed ratio which lowers blade bending stress, straight V or curved blades may be used. So, the challenges in the wind turbine design are: the strength of the wind is not constant. The wind may be sometimes the force from 0 or it can go up to storm force like a storm. So, we have to design the blade such that it can face all the wind speed. That is the first challenge. Next one is it is noisy. Each turbine can produce noise as a family car traveling at 70 miles per hour. It is harmful to birds. And it is manufacturing of wind turbine equipments is pollution. Pollution is produced during wind turbine manufacturing process. These are the challenges, but we get more reliable output energy from the wind. So, and it accommodates more power industry wise and residential purpose also, and it is always environmental friendly. With this we close the session on wind energy. Thank you.